All right, I'll turn off my camera because the connection seems to be quite unstable. Can everyone hear me? Okay, it's much better with the video streaming off, so I'll leave it off for now. So let me share my screen. Share. Do you see my screen? All right. So in preparing this session, I had a couple of options. I could postpone a couple of my hobbies and spend some time in preparing a very nice slide deck that I do very often for my customers. Or I could do my hobbies and then do something very ad hoc. So ad hoc it is. I'm here to talk about how we can run modern workloads in a very efficient way. And I'm going to illustrate a little bit how VMware and how VMware Tanzu, the whole modern application platform side of things, how that could help you do this. So we'll start with basically what we want to achieve. We want to run a modern application. Let's take, for example, a beer app or a sensor application or a very modern web front end with a Spring Boot backend and a nice little database behind it. We want to run it in one of the public clouds, or we want to run it in a private data center. All of these options are available to us, and the requirements will change everywhere you go at any kind of customer, right? So let us start by showing a little bit how it used to be. And let's go to like the basic concept of a couple of years ago where someone at a company had some servers and they wanted to run an application on that server, which meant you had to purchase the hardware, you had to purchase networking, routers, switches, you had to basically purchase everything you needed to connect these things, internet cables, someone had to actually come and physically do those things. You had to set up several servers if you wanted to have a high available setup. You needed to buy, at some point, you can buy hardware load balancers. All this stuff comes with a pretty hefty upfront cost. Nowadays, if companies that buy these large physical servers, these servers go up to 700 gigabytes of RAM or even more. They go up to 32 CPUs with hyperthreading of 64 cores or 64 threads. And those are hefty investments. Big enterprises like, I don't know, FedEx is one I'm talking to. They basically purchase servers in lots of 6 or even lots of 18 servers of these kind of big things. Each of them can cost up to 100,000 euros or more. So it's all a very big investment, a lot of work just to run some applications on a server and load balance across it and that kind of stuff, right? So it's a lot of work, it's a lot of manual work. There's not really a way of automating a lot of these things, except if you go like with Dell and VxRail, and there's a lot of standardization, and you got things like hyper-converged infrastructure where the network switches and everything are all like pre-built and pre-delivered in together. So, but that's not an ideal situation, and I think that's where VMware came in 20 years ago. They came into the virtualization software market, or they created basically the virtualization market. They built a very good hypervisor, which is basically a piece of software that runs on top of a piece of software that runs on top of your hardware, and that can virtualize virtual machines. So a lot of companies like Microsoft with Hyper-V, and now also the public clouds are offering the same kind of thing. So basically what we're doing is we're virtualizing compute, network, and storage. So where we had physical compute in terms of servers, we had physical storage in terms of real NAS or SAN storage hardware, and we had physical network hardware. we're now virtualizing all of that. All of the public clouds are doing this, even Ali Cloud, Oracle Cloud, they all have offerings where you can basically provision and self-service VMs, networks, storage, and you just pay as you go. In an on-premise environment in your own data center, of course, this is the hardware is pre-purchased, and that's coming from like the infrastructure budget, and then the development side can provision all these kind of things. You can set up software-defined load balancers in terms of we have NSX in VMware that can do software load balancing. And all these other tooling come into play there. You want to automate the software-defined data center with Terraform. You want to pre-provision everything with scripting tools like or provisioning tools like Ansible. You have to solve problems like EIM, who has access to what. You have issues like multi-tenancy. We need to be able to shield some kind of resources in separate tenants so that basically tenants cannot look at each other, see each other's networks, or see each other's workloads. So backup and restore are things that you need to take care of. So all of this are becoming things to take care of in the virtualization world. And it's a little bit better situation than hardware, doing everything manually. You can automate a lot, but there's still, it's not really the best abstraction layer for modern applications that we want to run and develop today. So when we go a layer upwards in the software-defined data center of next gen, we're coming into the abstraction layer of containers, where we think about containers. Everything around compute, network, and storage is around containers. So how do I build container images? How do I network them together? You have CNI implementations there, like Calico, Antrea, Flannel. There's loads of them in the open source market. There's lots of proprietary solutions. You have to take care of like, how do I connect storage to my containers? So I want to mount some storage. I want read write many, read write once. All these kind of issues are start popping up in the Kubernetes world. You have to decide which kind of container runtime you want to use. Everyone knows that Docker is a container runtime, but in the market there's already a lot of different ones like Container D and other ones. You have to look at load balancing. So the same kind of issues are popping up, but now in the Kubernetes world. You have to look at IAM, but in terms of policies, security policies, network policies. How do I deploy workloads in an automated way? We cannot really use Terraform or Ansible, or not as easily in the Kubernetes world. So we turn to new tools like Helm. We turn to GitOps tools like Argo CD or Flux, as you probably have seen in other sessions today. And for operating software or third-party software, often you find the concept of operators in Kubernetes. So all of these things are now popping up an abstraction layer above. So it's always on how to automate compute, network, and storage, but just on another abstraction layer. And what we really want as a developer, in my opinion, is you want to abstract and think about applications as the unit of measure. So you want to say, I want to deploy an application, I want to scale an application, I want to make my application available to the internet, I want to connect them together. And you don't really want to think about what does that mean in terms of containers, what does that mean in terms of VMs, and what does it mean in terms of hardware, right? You don't want to care about that. So preferably we go a level higher to some kind of application platform. We used to call it a PaaS, but since people are talking about hardware platforms, infrastructure platforms, container platforms, I think we should change this to application platform as a service, where it's unambiguous and we can say like, we're talking about applications as a unit of measure here. And in that regard, I want to talk a little bit today about Tanzu Application Platform. So this is our new application-based platform built on top of Kubernetes. So it can run on any of these Kubernetes distributions like EKS on Amazon, AKS on Azure, GKE on Google. It can run on Rancher Kubernetes clusters, on OpenShift, or even, of course, on our own Tanzu Kubernetes grid clusters. TKG is already multi-cloud, so it can run on-premise on vSphere, it can run on top of Amazon, on top of Azure, almost on Google's, they're working on that. And it can also run on top of, that's an interesting one actually, it can run on top of, if I go down a little bit, on top of vSphere, but vSphere in Amazon. So you have a way of running your vSphere stack completely in an Amazon data center. You have the same for you have VMware stack on top of Azure as well. So you can run a complete VMware stack and software-defined data center inside of the Azure data center, managed by the Azure people, so the Microsoft people, but supported by VMware. So you can just run TKG Kubernetes cluster on top of that as well. But in the end, like Kubernetes is an abstraction. You want to hide it away. You don't want to care about it anymore. It's bound to become a commodity in the near future, and you don't want to care about it anymore. You just want to have that Kubernetes API, and then we can build that application platform on top of it. And just to show to everyone the Tanzu website, we have the Tanzu Developer Center, so tanzu.vmware.com/developer. There's loads of topics that you can cover here about Spring. VMware is the custodian of the Spring framework. Lots of topics on Kubernetes, containers, microservices, and lots more here. There's a lot of guides that you can read through. And this is the most interesting part. There's a lot of hands-on workshops. I'm going to show you one hands-on workshop that is not public yet, that revolves around the application platform. Let me do just quick time check here. Yeah, that sounds good. So these workshops are fairly basic. It's how to build containers, how to run Spring on Kubernetes. But these are interactive workshops. So if you open one of these workshops, for example, building an application with Spring Boot, if you click on the Start Workshop, you'll see a interactive workshop where you can enter commands, you can enter a terminal, you have your own development environment, you can try stuff out, or you can just follow the workshop and follow along with all the examples. So we're going to do exactly that, but on the Tanzu application platform. So the beta for that was announced on Spring 1 at the Spring 1 platform 2 weeks ago. All the videos of Spring 1 are now publicly available on the website. So you can just look at the videos right here. If you log in, you can still register, log in, and look at all the videos. So let's have a look at the Tanzu application platform overview. So let's open up a workshop instance. And click here. So it's provisioning for me a new instance of this workshop. We're using a tool called Educates. If I look here and I go to Educates, it is an open source project started by people at VMware. It was coming from the people at Heptio that was acquired by VMware, and we're working on top of that. So Educates, very handy tool. It's something that you run on top of Kubernetes, and you can build all these different kind of workshops with it, which is a very interesting kind of way of sharing knowledge. So we are in the workshop right here. We have a terminal, we have a console, which is basically the Kubernetes dashboards on our cluster. So you're getting your own namespace in a running cluster. And we even have an editor available. We'll see that in a bit. So let's go over the Tanzu application platform. So the idea is that you work as a developer, you build your applications, and then at some point you just push your application code to the platform, and the platform should take care of building your app, containerizing it, running through your CI/CD pipeline, deploying it without an effort, and deploying it in an efficient way, allowing you to do like blue-green deployments, zero downtime upgrades, that kind of stuff. So let's get started. So we're going through this workshop through the eyes of personas. So right now we're working as Cody, the developer, and we're going to build an application. Our second persona is going to be Alana. Alana is the operator of the platform. We'll switch to Alana's viewpoint in a bit. But what we want to start with is we want to start creating an application. So what we have in store there is called the Application Accelerator. And it's kind of like the people who know start.spring.io, but for your own company, like for your own enterprise. It can be shaped and built up by the architects or by the developers, and they can define so-called accelerators. Now, what is an accelerator? And we'll go to the Spring sensors. So we already filled in kind of like a basic application. So this is one of the accelerators that we have. It's going to build a sensor application, and you have some variables that you can fill in. So it's completely templatable. You can have all these kind of options with free text fields, with drop-down options, with all kinds of radio buttons. So you can have all kinds of different possibilities of templating this. And then you can look at exploring the files, how that would look like when you generate it. And what you can see here is that there's already a Spring Boot Maven application. And something that you might not know or is not familiar is what we call the workload YAML file. And a workload YAML file defines our workload. This is like much smaller and more condensed than all the YAML you would need to deploy a regular Kubernetes application. You don't need to know all the ins and outs of Kubernetes to get really like a production-worthy application. So what we have is we have our own CRDs in Kubernetes. In this case, it's workload. We give the workload a name. We give it a type, so we can do web applications, functions, basic batch kind of like applications. And then you can define source control, like where do I find the source of the application, which Git repository should I check or watch. And then you can add environment variables. You can define the supply chain, which we'll see in a bit, that needs to be used to run this thing. And it will do everything basically to get your app running in production. So let's actually look at the workload. So we are a developer, and we want to generate this application basically to start with. So what we do is we do a curl towards this application accelerator and saying like, please give me a new project based on that Spring Sensors accelerator, and download that as a zip file. So we have it right here. So basically, it's like clicking the generate button, but in a CLI command. Let's unzip the zip file. So we get a whole project for ourselves. And then basically, we're not going to change much in the application. We're going to add all of these changes to our Git repository. We're going to add a Git commit message, basically adding all the changes. And then we're going to push this change. So now our changes are in Git. Now it's time to define our workload in Kubernetes. We're using the Tanzu CLI for that. So all you need to do to create and run an application in production is pushing this workload into Kubernetes. So what we do is we say Tanzu Apps workload create. We give the workload a name. We generate this YAML file, and we see what the output is. So this would actually give us this kind of YAML file, and it will generate this workload, or it will create this workload resource. Now, because we did that, there's going to be some things that are set in motion. The first thing that we're going to do is we're going to build the application. So what we do there is we use our Tanzu build service to take the source code from that Git repository and build it into a runnable container. So internally, it's using the build packs. In this case, because it's a Java application, we're using the Java Spring Boot build pack. So now it's downloading the internet because it's doing a Maven build. And then at some point, it will generate the application. So while it's building here, let's look at what the supply chain is. So by default, we have some supply chains that are very opinionated, that have a certain way of running, that we define, that we provide to the user. But the idea is that every company can basically build their own supply chains and integrate with tools like GitLab, Jenkins, GitHub, Azure DevOps, all these kind of default CI/CD tooling that basically any company has. So building a supply chain is typically done by architects or by the operator, some kind of middleware team, somewhere in between. So I'm going to show you how that would look like, how a typical supply chain could look like. It has a couple of different steps. So I'm opening the editor here to show the YAML file. And I'm going to have to be sensible of the timing. So as an example, what you define in this kind of cluster supply chain, so you can have a supply chain per namespace or a cluster scope supply chain that everyone can use in the cluster. And what we have to define is we have to give a source provider. So basically, we have a Git source provider that can read from any Git repository, but you could create your own source providers if you have other sources for code. We have an image provider, basically saying, how do I build a container image? And we're using the Tanzu build service kind of like built-in provider. And then we have basically a template, a cluster template for deploying the application. So this is also like the default cluster template for deploying. If we look at some of the pieces here and we have a closer look to the supply chain template, it's a lot of new stuff, but the idea is that most of this will be provided out of the box, and that the architects or someone with a good knowledge of the supply chain at the company will actually adapt this or change things, add steps, and fit it into their workflow. So if we have a look here, we have different images for each step, for building the image, for deploying an image. But most of this is already provided, is going to be provided by the platform. So it's working with sensible defaults, a little bit like Spring Boot, and it allows you to really break glass, as we say, and go deeper into the Kubernetes layer and change stuff. So what we're doing to actually deploy the application is going to be based on Knative. So it's going to be a Knative service that we create and that we deploy. So let's see how the supply chain is doing. So actually, we have all the logs here. So the application is already running. We can have a look in Harbor where we pushed the image. So Harbor is our container registry from VMware. It's completely open source and supported by VMware. So let's see to my repository. I have to go straight to that one. So for my workshop S156, it just created this new artifact here. So internally, the Tanzu build service created this image, pushed it to Harbor, and you can see it was build number 1 with a timestamp, and it was built like a couple of minutes ago. It's a full Spring Boot application, so it's using the build packs, and it's only 137 megabytes, and it also did a complete security scan. We have built-in pieces of the supply chain that can check the digital signature, that can do the security scanning of the image, and that can react when certain security vulnerabilities are found, fail the build, or notify people or stuff like that. So this image was built and it was already deployed as well. So we can have a look here and look at the Tanzu Apps workload list. So Tanzu is a plugin system. So if you press Tanzu, you have a couple of different plugins, but the only plugin we have now is Tanzu Apps. Tanzu Apps Workloads will give us all the available options, what we can do with workloads. And of course, we want to list the workloads. We only have one, but the workloads are listed here. Spring Sensors is ready. It has been ready for a couple of minutes now. So if we want to get the URL, it's being exposed with a Kubernetes ingress out of the box. So we can actually go to that link and look at our application. And you can see here, it's a sensor application. It's very dumbed down, very simple. It has an HSQL database in memory. And we can just click on a button and add sensor data, like random data, and it will show up. So it's being stored in. So very, very simple Spring Boot application as an example. Now, if we want to, if we want to change that application, well, let's look at the monitoring first, right? So we have something called Spring Application Live View. This is a new project that is almost out. I think it's also in beta. But basically what you can see here is that it can run inside of your Kubernetes cluster and watch all of your Spring Boot apps. We have one instance of our application right here. So if we click on it, we can see that it's our Spring Sensor app. It's running on a certain internal cluster IP. You can see most of the default information of the Spring Boot app. We can look at the health endpoint. If it allows me to do so. I think all the info is not coming through yet. It takes a while. Maybe the application live view is not connecting yet. So this is running next to the other application. Yeah, here it is. The status is unknown though. So let's go into the console. We should see everything running here. I think my connection could be unstable. Seems that way. Yes, okay, that's not good. Let's go to the deployment step. And let's look at the application live view. I think it's mostly on my connection. Yeah, there we go. So we have Spring Sensor running. There's two instances. They are both updated. If we click one, we should get more data out of it. Yes. Okay, the instance is up. You can see the environment variables from Spring Boot. You can have a look at the log levels. So basically all the Spring Boot actuator endpoints are being exposed automatically in this app live view. So application live view can monitor, or you can use it to monitor all your Spring Boot apps. It looks very similar, I would say, to the, what was it called? Spring Boot. I can't remember. Someone should say it in the chat, but there was a Spring Boot open source software project that showed you basically the health of all the Spring Boot applications. This is basically our version of it. You can look at the number of threads, the memory, request mappings, all of the stuff that you have in Spring Boot. It allows you to look at. Now, if we want to make a change in our code, let's quickly do that. So let's look at this part of the code. Let's have a look at the specific code. So it's opening up this editor in here. It's taking a bit. Connection is really not that well here. There we go. So it's opening up this file. Come on. That's the disadvantage of running this whole thing in a browser, but if you have a good connection, it goes super smooth. So let me open up this file. Come on. Okay, it's super slow. Finally, it's opening the code. So let's change, finally we're here, okay. Let's just change this to Ordina join rules. Close it. And then we can do a git commit. Let's push this change to main. And then in the bottom window, we should see the logs kicking off again. The log should be showing a new build. There we go. So we're building a new application version. The second time we build an image using build packs, it will only need to build the layers that have changed. So in this case, it's just one layer of the application code that changed. We don't have to rebuild the base OS or the middleware, like the Java runtime or the Maven dependencies. It's only our application code that changed. So it's a very clever layering system. We push the new version to Harbor. So we should see it in our Harbor. And then we can look at the Knative service. Status is unknown right now. Click the link. It also doesn't help that this environment is completely in the US, running in US West, I think. So if we keep refreshing here, we should see the Ordina join rules message. I think it's starting up the application now. It's shutting down the previous one. Give it a few more seconds. So it's using Knative to actually version the application. So we would have a 0001 deployment, and now we will have also a 0002 deployment. So let's have a look in the console if we can. Have a look. It's all going super slow. There we go. We have our deployments. We have the Spring Sensors 0002 deployment. We have our pods spinning up. And we have our services. So we have a private service for version 2, where it will temporarily start up until it's healthy, and then it will switch over to version 2 once it's up and running. So in here, we should see it running now. And I have to refresh a couple of times again. Maybe it's the caching. Refresh. Come on. Still showing the old one. Nope. Doesn't seem to be updating here. No, our code change is not coming through. Okay, I think it's because of the immense lag here. But this is where we're going to right now with the platform, right? So we don't want to involve all the developers in learning Kubernetes, in learning how to work with building a proper container, keeping it patched and up to date. We don't want to teach all the developers on how to best provision containers and how to set up pods and all the pod policies, network policies. This could be done by another team. or this could be done by an automated platform. So the idea is that we bring this Tanzu application platform on top of any Kubernetes, that we run this on AKS, EKS in the public cloud, or that we run this on OpenShift on-premise or Tanzu Kubernetes on-premise, and basically anywhere. And then it allows you to use the platform or just use the Kubernetes if you want to have that lower abstraction. The lower abstraction. So the idea here is to be able to run your workloads as you see fit. Use the platform and just write your own code, think about business code and nothing else. Use the standards and defaults that we define, or drill down deeper and basically start modifying, start overriding the defaults and doing much more, I would say, tailored work. So that's it for me for the Tanzu application platform. And I'm going to leave you with these links right here. So tanzu.vmware.com. You'll be able to try out the beta, run it on any kind of Kubernetes platform, and try it out for yourself. So happy to take any questions now. Thank you.